Hey everyone, welcome back. So glad you're joining us. In today's explainer, we're cracking open a brand new, absolutely crucial topic. Chapter 5, Lesson 1 on ratios. Ever looked at two groups of things in the real world and wondered, how do I actually compare these mathematically? Well, you're exactly in the right place. We're going to break the whole thing down step by step. By the end of this session, you're going to be an absolute ratio pro.
Here's our game plan for today. 1. An introduction to ratios. 2. Writing ratios with colons. 3. Visual examples where we'll be counting objects. 4. Some practice activity time. And 5. A quick lesson revision to wrap it all up. Let's get into it.
Section 1. Introduction to ratios. What exactly is a ratio?
Well, let's dive right into this fundamental question. I know ratio sounds like some fancy, complex math term, but the core concept is literally something you do every single day without even realizing it. Simply put, a ratio is just a comparison of two quantities. We use it when we want to see exactly how much of one thing there is compared to something else. It's really just a super handy way of showing the relationship between two different amounts. Whether you're looking at the number of boys to girls in a classroom, or maybe sunny days to rainy days in a week, you're basically calculating a ratio. It's all about comparison.
Moving right along, Section 2. Writing ratios with colons. The magic symbol.
So, now that we've got the concept down, how do we actually write it? In math, we absolutely love using symbols to make things quicker and a lot easier to read. And for ratios, our magic symbol is the colon. Those two dots stacked right on top of each other. When we write a ratio out, we just separate our two quantities with this colon. Think about it like this. If you've got a bag, and inside that bag there are 2 red balls and 3 blue balls, we write that relationship exactly like this. 2:3. And when we read it out loud, we just say 2:3.
But honestly, what does that really mean in the real world? When you see 2:3 representing red to blue, it translates perfectly into this sentence. For every 2 red balls, there are 3 blue balls. That's the real-world application right there. It tells us the exact makeup of our group. And the cool thing is, even if the group gets way bigger, that underlying relationship, that core comparison, stays exactly the same.
Let's move to Section 3 and see how this builds with some visual examples, counting objects like glasses and chairs. I always say math is way easier when you can actually see it right in front of you. So here we've got a mix of yellow glasses and blue glasses. To find the ratio of yellow glasses to blue glasses, you've just got to be systematic. First, carefully scan and count only the yellow glasses. Got that number in your head? Great. Next up, you count only the blue glasses. Finally, you just write those two numbers down, separated by our colon symbol. Yellow, colon, blue. See? It's as simple as counting one group, counting the second group, and putting them together.
But wait, what if the question asks for the ratio of blue glasses to the total number of glasses? This happens all the time, and it means you have a crucial extra step. You have to count absolutely all the objects first. Yep, the yellow and the blue combined to find your total. Once you've got that grand total in hand, then you can write the answer comparing just the blue glasses to that total number. Bottom line, always pay close attention to what exactly the question is asking you to compare.
Okay, let's try another one with these orange and blue chairs. Treat this like a quick, interactive counting game. Step 1, count the orange chairs. Step 2, count the blue chairs. And Step 3, write out the ratio of orange to blue by filling in those blanks. Now, quick reminder. If it asks for total chairs, you'd add the orange and blue together first before writing your final ratio, right? Following these systematic steps pretty much guarantees you're going to nail the right answer every single time.
All right, Section 4, Practice Activity Time. Let's test your skills.
So, we've covered the theory, we've walked through the examples together, and now it's time for you to actually apply this stuff. But right before we jump into the practice questions, just keep this one massive rule front and center in your mind. A ratio is always a comparison, and that means your accuracy in counting directly impacts the whole comparison. So count carefully, take a breath, and remember exactly what we're trying to achieve here.
Okay, here is practice question number 1. We're looking at some green and orange objects, and the question is asking for the ratio of green to orange. So, what's your very first move? You count the green objects first. Why? Because green is listed first in the question. Once you've got that, you count the orange objects. After you have both numbers, just fill in those blanks. Green comes first, then your colon, and then orange.
Let's level it up just a tiny bit with practice question 2. This time, we want the ratio of blue objects to the total number of objects. Remember our lesson from just a minute ago?
You count the blue objects to fill in that first blank, but for the second blank, the total side, you've got to count every single object in that picture altogether. Don't let it trick you.
Now pause for a second, because I have to warn you about the single biggest trap when it comes to ratios. Please pay close attention to this. Order matters. I mean it. You absolutely must write your answer in the exact order the question asks. If they ask for the ratio of red to blue, you literally have to count red first and put that number first. If you swap them and put blue first by mistake, you've completely changed the mathematical meaning of the whole comparison. So whatever you do, never swap the order.
So, the crucial point is, let's wrap this up with Section 5. Quick lesson revision. What did we actually learn today?
We have honestly covered a lot of ground today, from the basic definitions to visual counting and learning how to avoid that dreaded order trap. Let's look at our checklist of success to lock all this fantastic knowledge in. Checkmark 1, a ratio is a comparison of two quantities. Checkmark 2, a ratio is written with a colon. Checkmark 3, always count objects correctly before writing your final answer. Accuracy is everything. And checkmark 4, our absolute golden rule. The order of the quantities cannot be changed. If you keep these 4 things in mind, you've officially mastered the basics of ratios.
You guys have done a brilliant job following along with these exercises. Now, it's over to you. I highly encourage you to go ahead and independently solve the remaining practice questions in your book. Take your time, apply the step-by-step methods we used today, and definitely check your answers afterwards to see how much you've grown.
And that pretty much wraps up our lesson for today. If you found this explainer helpful and it made the math just a little bit easier to digest, please engage with the content. Like it, maybe share it with a classmate who might need a hand, and definitely subscribe so you don't miss out. Take care of yourselves, and I will see you right here in the next Math Explainer.
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.